Okay. I think what we're gonna do is switch back to the Advent of Code stuff that we were doing the other day. So let me update some of the title, or like the title and the stream stuff. Optimizing Advent of Code 2015. Okay, title should be updated. Beautiful. Okay, yeah. So we're gonna go through this again. Hold on. I messed up the tags. Let's fix that. Okay, so quick refresher. The idea here is we work through the Advent of Code days, and after solving the solution or solving that specific day, spend like 10 or 15 minutes just working through and trying to optimize as much as we can in that period of time. It's been a little bit difficult so far because we're already less than a millisecond, and at that point you just have a lot of system noise anyways, so it's kind of hard to like actually do anything. But I do want to go back over some of these solutions and just see if there's anything that we can quickly like think about, because I know one of these, I think this one actually ended up taking like more than a millisecond. So I want to see if maybe we can improve that in some way, but I think most of that time was spent in hashing. But maybe we'll even pull out like perf or something just to see if we can improve this. But yeah, so let's pull this back up. Where did I put that? Did I put that in here? I don't remember where I put that. Optimizations, this guy. Yes. Yeah, that guy. Great. Yeah, so let's open this guy and let's see. Yeah, so let's just if we where are we? Cargo R what is it? It's a binary. So day 1. If we time this, oh no, I've got an actually decent time. No. What is it? So there's cargo B, release, and oh no, it's a hyperfind that we did. So we had a hyperfind this script. So day one. Yeah, and you can see it's running at like 370-ish microseconds, which is really just way too fast. And like that ran 10,000 times in 3 seconds. So it's minimal the amount of improvement that we can make. And you can see like the variation here is like significant. It's what, 600 microseconds. So I don't know. There's not a whole lot we can do. But let's take a look and see if there's anything that immediately stands out after having taken a bit of a break from it. I don't actually think that there's anything on this one. Let's jump to what was it, day 4? And if I run day 4, what do we get? So yeah, you'll notice this one takes significantly longer. In fact, I don't want to run 10,000 times because that's going to take a long time. Yeah, so this one takes 105 milliseconds, which is significantly longer, but still like such a small amount of time. Let's see. So if I go to the TOML, can I do release debug equals true? Does that apply to these guys? Unused manifest key. Wait, is it build.release or something? I don't remember the... let's see, what is a flame graph? Like cargo flame graph, what does this say? Because I think it has that in the readme. Because you basically have to tell it to build with debug symbols. It's profile.release. Which isn't going to change anything here. Like the performance should be the same. But then we can do perf record callgraph Dorf on this thing. Or I guess it's in target release day 4. Yeah, and it's still really short, so we probably didn't even get anything. Perf report just G. Oop. Yeah, there's a bunch of like markdown MD5 stuff that I don't think we'll be able to do or deal with. And I don't remember the bindings in here. That's not helpful. How do you turn on the source view? Oh? No. Show that. No. Maybe not. I don't actually think this is going to be terribly useful. But also, like, how do I expand this? I thought it was right arrow, but that just moves me right. Let's see. Zoom into and annotate current symbol. Expand collapse 1 call chain level, so it's plus. Yeah. So if we go down here in part 2. Yeah, you can see we have like it's digest stuff. Copy from slice is slow. Let's go look at the source for day 4 again. So we're looking at part 2 specifically. Yeah, all of this stuff is in libraries. And I don't actually think there's really anything we can fix here. Which is unfortunate, but that's fine. Okay, so let's I suspect that the optimizations themselves are going to require a lot more as we progress, because it's just going to become more complicated problems. So let's solve day 6. Yeah, so let's grab the input. Day 6.txt. Close the file. Cargo toml. And we add our day 6. Okay, there we go. And then we can cargo R, or cargo B release. Where's that hyperfine? This. Oh, I forgot that I set the target there. So we set it. So we do our day 6. And we do day 6. And it failed automatically. And we do bin on day 6. Okay, not implemented part 1. Great, now let's read it. Because your neighbors keep defeating you in the holiday house decorating contest year after year, you've decided to deploy 1 million lights in a 1000 by 1000 grid. Furthermore, because you've been especially nice this year, Santa has mailed you instructions on how to display the ideal lighting configuration. Lights in your grid are numbered from 0 through 99 in each direction. The lights at the corner are 0, 0, and so on. The instructions include whether to turn off, turn on, turn off, or toggle various inclusive ranges given a coordinate pairs. Each coordinate pair represents opposite corners through opposite corners of a rectangle inclusive. Opposite corners of a rectangle inclusive. A coordinate pair like 0, 0 through 0 through 2, 2 therefore refers to 9 lights in a 3x3 square. I cannot read today if you can't tell. Sorry about that. To defeat your neighbors this year, all you have to do is set up your lights by doing the instructions Santa sent to you in order. How many lights are lit? Okay. So, how do we do this? My immediate thought is to... So I have done this, in case you didn't see the last stream, I have actually done a couple of these challenges already, but they were many years ago and I genuinely do not remember solving them. So I don't actually know what part 2 has, but I do, what was it? 40410. I do suspect, part 2 will be taking one of these numbers. So either this 1000 by 1000 or like 99 or 999 or something, or both, and making it significantly larger, which kind of scares me. But let's look at the input. What does the input look like? So turn off this range, or these points through this points, okay. And turn on our toggle. So that's fine. Let's parse this first. So what is that going to mean? That is going to mean what? Input.lines.map. So L starts with turn on. Yeah, we can just walk through this like this. Oh, these aren't bytes. So if our line starts with turn on, then we're going to... I mean, I guess we can just use an enum. There's not really any reason not to. Turn on. I guess what would this be? This would be like an instruction. Turn on, turn off, and toggle. So if we get turn on, then we do instruction turn on. Otherwise, if we get turn off, then we get turn off. Otherwise, if we get toggle, then we get toggle. And then otherwise we can just panic. So this is going to be the instruction. And then I also want to pass in rest, which is going to be if let sum rest is this. And we're going to say strip prefix. And this way we can get to, let's see, if we pull up the input day6.txt, this way we get turn off. And then we just end up with some numbers, and then we can parse those. So turn off. And then toggle. Like that. Expected U32 got that. That's fine. Let's keep our to do here. And then this is gonna be the lines, which is eventually going to be an iterator, I think, over instruction, then start and end, which we're about to parse. So start is going to be pretty simple. It's going to be what, L split once, splits the string on the first occurrence, or I guess we can split white space. No, let's just split once on space. And then this is going to be start and rest. Then we can say rest.r, oh, and we can unwrap here, that's fine. Then we can say rest.r split once on space. What is r split terminator? Separated by characters. The pattern can be that. Oh no, I don't care about that. R split once on space, which gives us end. What does R split once do? Does it give you, what's the order? Okay, you get them in the correct order, so it's gonna be underscore end. Like that. Unwrap as well. Okay, so now we've got the start and the end. We just need to parse them. So let's start is start.split once at comma, unwrap, then we can parse each one. And same thing for start and for the end. And it doesn't know what these are supposed to be, so these are U32, 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 or I guess even something smaller is fine, like U16. Like that. Oh, and these need to be unwrapped. Okay, rest here is wrong because this should be rest. And now we've got a line, or like this iterator, which yields these weird tuples. Okay. And I guess let's collect that into effect. Now what? So furthermore, because you yeah, don't care about any of this stuff, how many lights are lit? So now I think we can just loop from 0 to 1000 on the X and Y. And then like honestly, I would even want to say instead of start and end being like this, I would want to say like X start.0 or end.0. End.0 end.1. So these become ranges of U16s. So that we can just say for line in lines. And then we can say let mut state equals 0, or I guess false. Match line dot, or I guess if line dot let's say inst x range y range, if x range dot contains x and y range dot contains y, then we're going to match on the instruction. If we get turn on, then it's just gonna be lines dot what is this? It's literally just state equals true. Turn off is state equals false. And I have a thought here that we don't need to loop this way. We can loop the other direction. Meaning that, like, if we get, like, instructions that are on, toggle, off, toggle, on, then it doesn't matter what these instructions are, because the last one says on. So we can loop backwards, and I think that's an optimization that we'll end up making. So looping over lines, this needs to be by reference, this needs to be by reference, this needs to derive clone and copy. Cannot move out of shared reference. Oh, because these variables don't have that. That's fine, they can be references, I don't care. State true, and then toggle is just gonna be state. Can I do this? Yeah, I can. But that's a little bit confusing. Let's do state equals not true. Not state. Okay, and then here, or I guess sum plus equals if state 1 else 0. And then we run that, we get explicit panic on line 18. Line is this guy. Which probably because I'm reading the wrong day. Wow, that took a while and was wrong. Probably because of these range checks. This is supposed to be inclusive, right? Each coordinate pair represents opposite corners of a rectangle inclusive. Yeah. So these should be that, and this should be start. And this should be end, or start.1. Still really slow, but it is correct. Okay, how long does this take? 2.14 seconds. Fantastic. Let's take a peek at day 2. You just finished implementing your winning light pattern and you realize that you mistranslated Santa's message. The phrase turn on means you should actually increase the brightness of those lights by 1. Turn off means that you should decrease by 1. Toggle means that you should increase the brightness of those lights by 2. Okay. Great. That doesn't seem terribly complicated. And I'm probably going to regret saying that, but we're going to find out. So let's yoink that and paste that there. Input is called input. And then, oh, did I paste it twice somehow? Great. So now sum is going to be here. Turn on means sum plus equals 1. Oh, to a minimum of 0. So we do need individual brightness. Which means we need brightness is 0. Brightness plus equals 1. Brightness dot saturating sub, which subtracts, and then if you're at 0, it just leaves it at 0. And then toggle means that you should increase the brightness of those lights by 2, because that makes sense for like a command called toggle. But whatever. And then state or brightness. Can't call method saturating sub because it doesn't know what this is, even though it's a U32. Match has incompatible types because this will be brightness equals. Great. And then if we run this, in release mode is fine. We get an error. Did I paste it 3 times? No, wait, this is part 2. Wait, what did I do? Or part 1. I don't know what I did. Okay. Now, yeah. We're really, really far off. Because we never copied this new number. Not like that. This guy. Okay, now we're correct. Good. So, let's just do a quick hyperfine on this. So what is this? Day 6? How long do we take? 400 milliseconds is actually pretty fast. Thought it was going to be quite a bit slower. This doesn't match that 2-ish seconds that I said before. What was it? 2.14? Yeah, 2.14 seconds that I said before, because now we are compiling in release mode. Okay, so that should be running. It says about 5 seconds left. I mean, I guess there's not really a whole lot of point to doing this. I'm just curious, what does a cargo flame graph look like? Oh, that is, why is it like a debug output? That's kind of weird. If I do Firefox, you're gonna open in the correct thing. You are not. It opened in my, like, really? That's fine. PWD. Is that not what it's called? It's called Flame Graph. Flame Shot. Oh, that's my screenshot tool. Flame Shot. Flame Graph. That is really, really bright. I am sorry. For my eyes and yours. Yeah, I wouldn't expect this to really do a whole lot. There's range bounds contains seems to be really, really, I don't know if it's slow or if it's just called a lot. That is one of the issues that I find with the flame graph is that okay. It's kind of hard to see whether something is slow or if it's just called a bunch. Which I guess is kind of just not what it's made for. So that's whatever. It is really funny to see that the file, like IO operation, is nothing. I don't even know if that'll show up on the stream, but it's like probably 1 pixel thin. Like, absolutely tiny. Okay, yeah, that's kind of useless. Let's do a perf record on day 6. It's still a super tiny amount, so it's probably not going to give a whole lot. Perf report. Part 2. That's interesting. Part 2 shows up, but part 1 does not. Don't know what that's about. So just iterating takes a while, it seems. And then the contains check. I'm gonna let's try something. So let's get ignore the perf.data. And the star.svg. And I'm doing like generics there because we might end up copying them for like testing purposes. What's our diff? Okay. Day 6. Just so that we can have something to go back to if our changes don't end up working. So I do still have that idea for implementing this where we walk backwards in the list. But we're gonna have to see what that is. But that isn't really possible to avoid on the this case and the part 2, because we do need a sum. So we're gonna see about that. But yeah, first thing I want to do is just, instead of doing this, let's do what we were initially planning and just have a start and an end. Oh, we're supposed to do a timer. Tab timer. 10 minutes. Let's go. Okay, yeah, so I want to basically say we have a start and an end. And I just want to say if start.0 is less than or equal to x and end.0 is and x is less than or equal to end.0 and start.1 is less than or equal to y and y is less than or equal to end.1. So that's basically the same bounds check, but this time it's not using the range, so it might be a little bit nicer. Maybe, potentially. We're gonna find out. Oh, this is called start and this is called end. So now if we cargo, or let's do this guy again. What was the number before? What was the number before? Oh, this guy. It was about 400 milliseconds. This one is actually quite a bit faster. I didn't realize that range checks were a point of concern. I guess we probably don't need to actually run this 100 times. But I guess it doesn't really matter. So yeah, we're about that actually did about an 80-second speed up. That's pretty cool. I want to try this. So let's 3 lines is instant now. And this is obviously not going to be super great. It's pretty not a great method of profiling, but it's good enough. I just want to see how long it takes to actually do this parsing. 22 microseconds. Is there anything that we can like immediately improve in here? There's the integer parsing here. That's not fantastic, or I guess not that. But that's not necessarily fantastic. Technically we could do SIMD or something for splitting, but I don't think that's worth the time. Because this is something that we run once like 300 times. Let's actually keep this pre-line stuff. I'm gonna write a custom parse. Although, is it really worth it? So it's gonna be up to 3. Yeah, I don't know that there's any reason to do so. Actually, I mean, fuck it. Let's write S is a stir, and it gives us a, what are we doing? U16. For B and S dot bytes. Or I guess we can even do I in 0 to S. Or no, we can do S dot, what is it? S dot bytes dot take 3. And this will only take up to 3. Or fewer if the underlying, yeah. So let mut out equals 0. Out times equals 10. Out plus equals I minus 0. And to be honest, this could just be a U8. There's no, it can't be a U8. It goes up to 1,000, so it has to be U16. That's fine. So we turn that into U16. Cannot subtract U16 from 8 from I. Wait, cannot. Oh, no, that's supposed to go there. And then if we use our parse, this one isn't fallible, so it's possible that it's a little bit faster. But I'm not terribly confident in that. Let's see. Parse n.0, parse n.1. And let's put that up in here as well. Yeah, I don't think it's going to be any faster. In fact, it's actively slower. Okay. If you say so. That is fine with me. I'm not terribly concerned about that. I think the oh, actually, no, let's redo all of that. I wanted to specifically see what this showed. This does show a lower number, but that is still, it is consistently lower. So let us actually run it. Might as well. Yeah, it is a touch slower, which is interesting. Oh, I guess we do still have this debug print. That would do it. Yeah, I feel like that had an impact on there. Yep, quite a bit. But really what this means is that there's not really any change. You get 32.4 or 324 milliseconds versus 325. So basically the same. That's fine. What else do we have? So this strip prefix, again, I don't really think the lines is the concern. I think it's literally this iteration that's a concern. So we're gonna, yeah, it ends up being basically identical. Let's time this individually. So part 1 right now runs at a whopping 148 milliseconds. 147 milliseconds. Okay. Now, if instead of walking like this, we said lines.rev, and then if we get, not this one we actually do have to walk all the way through, because we need like the sum. But if here we did iter rev, then we can do state equals true break. No, you actually have to break here. State equals false, and then break. Otherwise, we need to say let mut toggle is false. And then toggle equals not toggle. And then if, this is weird. Wait, hold on. So toggle in this case is, okay, let's write out an example on this. So we have on, off, off, on. Then toggle, I guess, and on. Yeah, sure. Well, let's keep it super simple. So if we walk through this vertically, we get on, then off. So let's just annotate the state afterwards. So we get on, then off, then we get on, and we get on. So this case is simple. We hit this on, and we know that the end result is on. It doesn't matter what the previous stuff is. So if this was like this, then this becomes off. But we still get on at the end. Oh, there's our timer. We're going to dismiss this because I do want to pursue this. It seems interesting. Welcome to the stream. Should be developing for our server. Yeah, probably, but I'll do that at some point in the future. Yeah, so, okay, you finish. So on toggle, if you finish with an on or an off, then you can do that. But if you finish with a toggle, you do need to walk backwards and see what the state is. Which is not a big deal like this. So like for this, you could see what the next one is behind it. But if you have toggle, then you need to like build up a history. And so I think this is going to be done with this toggle false. So by default, if you have on here, then toggle is false. But then if you hit this toggle, then toggle becomes true. But if you get two toggles, then they kind of cancel each other out and you get what the previous value is. So I think that's what this is going to be. If you have true, then you need to toggle the state down here. The state, so if toggle state equals not state. And we could switch this here to rely on toggle. So this is not toggle, and this is toggle, which I think is a little bit confusing, but I think should work. Let's see. It does not. Does this part work? It does. So why is that not okay? No, wait, is it supposed to be toggle and not toggle? Toggle doesn't sound like a word anymore. That's interesting. That should work, I think. Right? Why does that not work? I don't know. I don't really care. I think this is fine, actually. There is a case here where we never turn on a light. Right, like we walk through this iterator. I don't know if that's okay, but I'm going to assume that it is. I assume somewhere in here it says that all lights start at off, because that's how the function... That's how our current implementation assumes. The lights all start turned off. So yeah, by default they're off. Okay, let's hyperfind this. Oh, wow. Okay. So before we were getting 150 milliseconds, now we're getting 25. Yeah, we're getting 147. Now we're getting 25. So that's what? I can't do math. 150 divided by 25 is 6 times. That's 6 times faster. That's pretty good. I don't think that this matters, but let's do state, or I guess U32 from state, just because it makes me feel better. Wow, look, that was so good that it gave us an extra millisecond. I mean, obviously not, but whatever. Anything else that immediately stands out? Because our timer did go off. Nothing I can immediately see. I don't know of a good way to improve this one. We do definitely need to get the brightness. And I don't see any benefit to like walking backwards or anything. So, okay, I think we're good with this. Let's do a final benchmark. To 200 milliseconds. We started off with about 400, so we got it to about half the speed that it was originally. Or I guess twice the speed that it was originally. Yeah, we started at 401. And now we're at 200. So that's pretty good. I consider that to be a success. That has, up to this point, been our most successful. Optimize day 6. Let's just put a note for what we optimize. So what do? We use direct comparisons rather than range contains, and iterate backwards through the instructions for part 2, part 1. Okay, let's go ahead and push those and start on part 7 or day 7. So in cargo toml, let's create this day 7. Oop. And then let's copy the template to day 7 and open the input day 7. I keep typing 6. Slash input. Oh, it's this one. I mildly recall this puzzle. I'm curious, did I solve this in the past? If we go to GitHub advent of code. So these are my solutions from the past. Apparently I did them in Haskell. Or I think I did them both in Haskell and like one in TypeScript. Yeah, so I have, oh, it says work on day 7. This was also 5 years ago, so it's been a while. I guess maybe I did day 7? I don't actually know. I've got the Haskell one. Oh, I guess we can look here. If we look at here. No, we look at here. Day 7 has not been completed. Okay, well, hopefully I can solve it today. This year, Santa brought little Bobby tables. That's fun. Is that like a... No, there's not even a link or anything there. A set of... That's an XKCD. Let's see. XKCD Bobby tables. Yeah. A classic XKCD, too. Does it have a year or something? I don't know if he puts those. I didn't know there were explanations. I guess I've seen that there's explanations, but I don't know if I've ever actually like spent any time looking at the site. I mean, there's a timestamp from 2012 on here, so yeah, this is an old one. 2007. So yeah. Oh, this is the XKCD site that I'm used to. What is this? Oh, this is okay, yeah. Okay. Hi, this is your son's school. We're having some computer trouble. Great post. XKCD is fantastic. Okay, this year Santa brought little Bobby tables, a set of wires, and bitwise logic gates. Just the Wikipedia page. Unfortunately, little Bobby is a little under the recommended age range, and he needs help assembling the circuit. Each wire has an identifier, some lowercase numbers, and can carry a 16-bit signal. A number from 0 to 65535. Great. Signal is provided to each wire by a gate, another wire, or some specific value. Each wire can only get a signal from one source, but can provide its signal to multiple destinations. A gate provides no signal until all of its active inputs have a signal. Until all of its input have a signal. Okay, so obviously graph-like structure here. Oh, fuck. I kind of mildly disassembled my setup for drawing tablet while doing some desk rearrangements, so it's going to take me a minute to set it back up, but I think I'm going to need it, so I'm going to do that. While I do that, let's just take like 2 minutes, and I'll be right back. Okay, tablet is set up. I'm going to create like the Krita drawing, whatever. She's 111 No, not even that. Let's do 18. Okay. Create. Okay. Just because I think I'm gonna need to draw this out to reason with it. But now we've got drawing ability. Okay, so we can see through here. Let's I think we're definitely gonna need the example input, so let's grab that. And then before we even do anything, let's parse and just make sure that everything is happy. So day 7. I want to say input.lines.map. Honestly, we can just split white space. This is regular. So we have 2 cases. We've got a value, or we've got no, we have 3 cases. We've got a value, we've got a binary instruction, or we have a unary instruction. And each of these can be determined based on the length of items. So split white space gives us... It's a little bit annoying. It gives us like an iterator. I think it's fine to collect. We're not doing a whole lot of parsing in here, I think. No, I don't care about the type. Okay, that. And then we do this inside of a block, obviously. And then let's match on parts. And so we can do some pretty advanced pattern matching here. We can say value. We can say an arrow. And then the out. And I think that this pattern matching should work. Rust gives you some pretty functional like pattern matching. Expecting array or slice found vec. Right, we need to turn this into a slice. Unused variables. Fantastic. So it is dereferencing, or not dereferencing. It is pattern matching that correctly, which is cool. Let's create a struct call or an enum called connection, which is going to take in, or it's going to be one of these variants. So it's going to be, I guess, just a value, which takes a. They said they were all U16s. Yeah, 16 bits. U16, and it gets placed onto a wire. But all of these get placed onto a wire. So I'm gonna say that this is like an input. So you get a single value, or you get. Do they just have like a list of instructions? That'd be really cool. Because it says bitwise and, but it doesn't actually say which operators are supported. Yeah, I don't see it saying that. Which is a little bit annoying, but that's fine. So we'll say and takes in, I think these can only take in like wires. So that's fine. So and takes in, how are we going to represent our wires? I mean, we could just use static stirs. That'd be a bad idea, but it would work. It's fine. Let's do strings. So strings, so and takes 2 strings, or takes 2 strings, or two incoming wires. Oh, other possible gates include OR and R shift. If for some reason you'd like to emulate the circuit instead. No, I'm not going to emulate it. I'm going to build it out on a breadboard. How many Yeah, there's a lot of stuff in here. That'd be a pretty busy breadboard. Okay, so we have and, we have or. We have L shift, which takes in a wire and it seems to just be a number. So we'll take in a U16. Same thing for R shift. And then finally we have not, which takes in a string and will invert the values on it. Okay. For example, here's a simple circuit. Let's parse this circuit. So we have the in. Oh, that's a word. So input. This is going to yield input, and out. Or input, no, not input, input value, input.parse.unwrap. Unwrap. Okay, so that will give us our U16 and the destination. Although, honestly, let's have this be out and that. And then we're going to say, let connections is a hash map from this to this. And we'll collect on this. Parts is borrowed here. This needs to be toString. Okay. And then what? What are you complaining about? Field 0 is never used. Can I just do pub and then it stops complaining? Very nice. Input. So what's next? We have and, which is x and y. It's gonna be and x to string, y to string. Same thing for or. What else do we have? L shift. And then this time y is going to be parsed. And same thing for R shift. And then finally we have not. Which is just that guy. Okay, very cool. Then I just want to debug the connections. Can I bless your three finger canes combo? No, I can't. I'm sorry. That goes against my what do people prefer, like Chick-fil-A? Yeah, that goes against my Chick-fil-A priorities. No, not day 6, day 7. Explicit panic on line 35. Sure, let's say what this line is. You can't pray for you? No, for me, I cannot pray for you. If you had God's chosen shitty chicken place called Chick-fil-A, then I would, but I can't. Oh my god, I fucking did it again. Day 7. Can I do, there's module path. What does this give? Or I guess, no, that's gonna be, what does file give? Source day 7. Because we could technically extract it from that. Or, I mean, we could even do, like, module path. What does this do? It literally says day 7. We're going to use that, because it's stupid, but we're going to use it. So, template. Nope. Template. Here we're gonna say format, or I guess not even format. We can just concat. Module path, and that's okay because we're in like distinct binaries. I just DoorDashed some Chick-fil-A. Can you bless it? No, because it's not God's chosen shitty chicken. Canes. Okay, what is our thing? We failed to parse on an invalid digit. Great. Let's run the example. Oh, is the assumption I made here wrong? It might be. Let's see. Debug parts. LX2A. Really? You can just have direct connections? That's stupid. Connection. Okay, dot parse, dot map, input, value, dot unwrap, or else, input connection, input to string. Like that. Closures, oh, because it takes the error. Okay, so that does parse it, which means that my assumption about everything is correct except for this can be another cable. Are you playing NCR music? I don't know what that means. Using a service called Chill Hop, and they play whatever the fuck they want. I'm currently on Sunshine Beats as the station. Okay. In Little Bobby Kid's instruction booklet, as provided your blah blah blah, what signal is ultimately provided on wire A? Okay, so non-copyright music, yes, maybe, no. I think this stuff has copyright. It's just like publicly usable, so it's royalty free. Okay, I'm gonna draw this because I think I have an understanding, but I want to visualize it a little bit. So let's actually draw this specific thing. So I'm gonna just put this over here. Does this float? Ah, shit, it doesn't. What is the... that's not the right thing. What is the binding? Mod Shift S? A, it is. Okay. So I'm gonna put that right there. Oh, goddamn it, I just pressed escape on accident. Picture. I don't know if you guys can see the screenshot tool that I'm using, but I'm taking a screenshot. We can do that, we can do that. Do that. Okay, now this time do not press escape. So in this example, we have all of these wires. Let me drawing tablet front and center. We've got all of these wires. Actually, this is a weird example because it does specifically ask what is the value on wire A, and this one doesn't have a wire A, but that's fine. Let's just do wire D. It doesn't actually matter. Well, I cannot use my computer today. 4. Why did it rotate? What am I doing? What have I done? Okay. I don't know if you can. Oh my god, what the hell? I don't know if you can tell, but I don't use Krita. I think I literally installed it like 2 days ago. Okay. Great. So we've got 1, 2, 3 as a value provided to wire X. We've got 4, 5, 6 as a value provided to wire Y. And then just like going down this list, we've got D, which is effectively an AND gate here. And AND is a bit weird because these are bitwise operations, but we're just going to roll with it. We've got wire E, which is an OR gate. I think I have these pictures like correct in my head, but I think that's an OR gate. And then Y also goes in there. And then X, like left shift. I don't know how I'm going to represent left shift, so we're going to just put a box, not that kind of box. A left shift box. This is beautiful. 2 goes to F. And then Y, R shift 2. Goes to, I guess these are arrows because everything is directional. Right shift 2 goes to G. And then like not X. I don't feel like drawing because it's, I guess X is right here. Anyways, this. Wow. Oh, what the hell did I just do? Okay, I think Control X somehow like deletes everything. So not for H, and then finally, ooh, one might even think I was just drawing on a mouse with how bad this is. I. So this is kind of the layout. This isn't a great example in terms of the recursive nature of this, but I think for each individual wire in here, we can take it. In fact, let's switch back to a different color, so like that orange. And I'm not done with this pen, good sir. So like for F, or I guess for E, why not? We take this one and then we like start walking backwards. We figure out what source is E, and so it's this OR gate. And then we look at this and we see this OR gate has 2 inputs, both this X and this Y. So we're gonna look here. What does this X require? It's this 1, 2, 3. So we have like an actual fixed value. And then this Y, what does this require? 4, 5, 6. So now we have 2 fixed values, and then we can like, there's a term that like AI people use, AI bros. Well, not AI bros, because it's actually people who know what they're talking about, but like back propagation, I think is what they use, and that's effectively what this is. But this is ultimately just like an interpreter. Like that's just what this is. That's okay. I don't know why I have had issues solving this in the past. Like it feels pretty straightforward. And I'm probably going to deeply regret saying that, but we'll see. Yeah. So right now, you'll notice I put the keys, or the keys of the map are the results. No, it's not, you scam. What am I scamming? I never scam. So the key right now is the result. So like in this, god damn it, I keep pressing the wrong buttons. In this case, X has, X is the key, and then 123 is the value. Okay. Yeah, great. So if I debug connections at A, I don't even think I need to, I guess I do need to reference that. If we do that, you'll literally just see we've got LX. So we can just basically start walking backwards and resolving things. So in order to resolve, we're going to create a resolve. I guess there's no reason this can't be in here. Ooh. Impl. Input. Let's go to resolve function, which takes in the... See, it's interesting. This connections map is basically like a variable map with like lazily evaluated expressions. Kind of like you would have in like Haskell. Which is just kind of interesting. But no, so resolve for now is going to take in the self and connections, which is a hash map of string to self. And it's going to return a U16 because everything should be resolvable. And so first up, we got to match on self. If we get a value, then we can just yield that value. That's an easy one. Otherwise, we're going to say connections at v.resolve connections. And this takes by reference. Then and is pretty simple, so we take x, y, we say connections at x resolve, and then we say and connections at y resolve connections. Same thing for or x, y, and then instead of and, we're going to do or. And then for left shift, we have an x and we have a y, but this y is not a value or not a variable. It's just a constant. So we can just shift by that. And the same thing here, except it's R shift. And then not is going to do connections at x. We're going to resolve that. And then we're going to binary not that. And that this, in Rust, the bang operator is equivalent to like tilde in other languages. That does tend to trip me up. But it is perfectly fine. Okay, resolve. I don't know how I just managed to do that. Before we do this, and so this one we don't actually have the output, I want to confirm that all of these values are correct. So day 7 EX, we resolved to 72. Let's not print this thing anymore. So we resolved to 72. EFG HI. So EFG H I X Y. Let's see. So 52, 507, 492, 1. Okay, so G seems to be wrong. 65412, 65079, 1 2 3 4 5 6. So G, what is G? G is an R shift. So we have what, 1824. G is 114. So it's a logical shift, right? Is that distinct in some way? I don't think it should be. Like, I think, yeah, according to this in Rust, it's that, but it does have a footnote. For unsigned types only, which is what we're using. Shift left in standard ops. Why is... I don't care. Oh, am I... No, it's R shift is shift right. Oh, that's the issue. I'm doing that. Yes, now we're getting 114. Which means that if we come back here and we instead do where is it? For our answer, we instead do A. We get no entry found for key on line 65. Oh, because we're still using the example input. This is one thing I don't like it when Advent does. Generally, they try to avoid this. I think, or I guess it's literally just Eric, I think, who creates the puzzles. But when you have to pass in like different input to solve the second day, or like the code actually has to change to solve the second day versus the examples, it's a bit annoying. But it's okay. No entry found for key on line 20. Well, that's interesting. What's the key? Oh, well, it could totally be the other. Oh, you know what? It's probably going to be an integer. Yep, it's an integer. Okay, so, fuck. That's a little bit annoying. Basically, this can be an integer. These can be integers. I guess connection can't be, because we're doing this, but I bet any of these inputs can be integers. So let's account for that. How do we account for that? I mean, really, we just replace, yeah, let's create like a pub enum value, which can be either a wire or a value, a constant. No, a value. Like that. And then we have impl on value, which literally just says pub fn resolve. It's literally the same function, except we're going to match self. And if we get a wire, then we're going to say connections at that wire dot resolve. And then if we get a value, then we can just yield that value. Oop. That's definitely not what I meant to do. Okay. And we need to dereference that, of course, as everybody knows. And then each of these can be a value. Value, 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 value. Everything is a value. This is not going to resolve. That's a value. This is, yeah, okay. These are supposed to be input. X and Y here are values, which means that you no longer do connection at, you just do resolve the values themselves. Beautiful. Okay, tuple variance defined here. Right, so let's do pub fn from stir. And the reason I'm not going to use like the standard library from stir, so we could do like dot parse, is because I want to, actually, no, you know what? Let's do that. We have infallible. S dot parse. I guess dot unwrap, or no, not that. It's gonna be map, self y or self value, unwrap or else it's going to be value wire s.into. Expected R parent. Like that, and this needs to be okay. Great, so now we can keep this parse. Instead of being connection or anything like this, it's literally just going to be input.parse dot unwrap. This is going to be x.parse dot unwrap, x.parse dot unwrap, x.parse dot unwrap, y.parse. This one's y. Unwrap, parse, unwrap, almost done. Parse, unwrap, parse, and unwrap. Okay, input parse is not a thing. Input is that. Oh, this needs to be input value. And now it's running. And hopefully it doesn't have like a loop or something. Why is this taking so long? I would not expect it to take this long. Fuck. I don't know if it's stuck or if it's just slow. Both of which kind of concern me. I guess. Wow. Let's just debug connections here to make sure everything here is fine. And I guess we'll just run it in a separate thing. Obviously an error. So yeah, that's fine. So it is definitely just the resolution that's bad. Yeah, so I guess a big thing we can do here is after we've resolved something, we need to cache it. Yeah, I'm not even going to bother saving that. We need to do effectively memoization. Although an alternate method to memoization that we could do, this needs immutable reference. Immutable borrow later used by call. Right, that's going to be a pain in the ass, isn't it? Fuck. Okay, so that's kind of weird. Yeah, okay, I was gonna say let's just update the connection and replace, like, once we resolve something, just replace it with value. But I think that's gonna be kind of weird, and that's gonna make the lifetimes be a pain in the ass, and it's not really worth it. So let's do a memo, which is a hash map of string to input, string to U16. That is for memoization. We're gonna do some dynamic programming here. For those of you who deeply loved your data structures classes, or I guess data structures and algorithms, DSNA. Yeah. So if we get a wire, we're gonna say memo get w dot, or I guess entry w. What does entry take? It takes a key, which is econ hash. Oh, but it takes the key itself. That's a little bit annoying. We'll see. Or insert with that. But it's annoying because now I need to do toString here. And then I guess deref. And what is insert with? It's an F and 1, so it's empty. It takes 2 arguments, but 1 was supplied. So this is going to be the memo, which is now... Fuck. We might not be able to do this using the entry API, which is really sad because the entry API is super useful. That's fine. Let's just say if let sum memo equals memo.get w, then we're going to say memo. Otherwise, we're going to say let value is going to be this computed value. And then we're going to say memo at w equals v. Does that work? Do you have to use insert? And then we're going to return v. Yeah, you need to be dereferenced. Yeah, use an insert. Cannot assigned. Index mute is required to modify index content, but is not implemented for that. That's interesting. Yeah, we're just going to use insert. What the fuck? No, memo insert w dot into, or I guess clone, and value. Okay, perfect. And then we basically need to do that same thing for here. So this is, what is, like, these are values. So I want to just do, like, let resolve is this. And it takes the v as a value, and it returns a u16. V as a reference to a value. Just so that we can, so that we can what? So that we can, fuck it, we're gonna call this W for a wire. Oh, it's a value. Oh, yeah, so it's literally just gonna be value.resolve. Actually, all of this can stay the same. This just needs to be memo. This needs to be memo. This needs to be memo. Wait, no, I'm making things up again. I'm being full of shit again. Yeah, we need to do this. We're gonna say if let sum, or I guess match on v. It's weird, wait. Connections at w.resolve. Yeah, no, we always end up calling into here, even in the recursion. So no, I think we're cool to just say this is all the same, but this takes memo. And then this needs to take the memo, which is just be mutable default. Not yet implemented part 1, which means it resolved like instantly. So we get 16076. Fuck it, let's try it. Hey, we get it. The power of dynamic programming. Okay, now take the signal you got on wire A, override wire B to that signal, and reset the other wires. What new signal is ultimately provided to wire A? That's such a confusing bit of text. Also, this needs to return that like this, and this is going to be returning a 16, and this is going to be comparing to this value, and this is going to be, so input is like this, and arguably we should move this like parsing stuff into its own function, but that's a problem for later. And then here we can say let A is this, and then now we can say connections dot, what is connections at B? I'm gonna comment out part 1 for now, and then leave this as a to do. What to do? You're unhappy because of reasons. You're unhappy because of that. So B is a static value already. So we just need to update that static value. I think we can literally say connections.insert b.into. And then here we're going to say input value A. Like that. So we just override that value. And then we're going to run this function again. And return it. Which means that this needs to be updated to U16. And we can do everything like this. This doesn't need to be borrowed. Connections cannot be borrowed as mutable. That is fine. We can make it so. And then we update it here. We replace the B, so that's this step. Override wire B to that signal. And then we reset the other wires, including A, which basically just means remove our like memoized values. And then what is the new signal ultimately provided to wire A? So that's this comparison. And then this is obviously not correct, but that's fine. We run it. We get 2797. Do we trust it? I think we trust it. We do. Hell yeah. We got the gold star 11 years late. But we got it. We got it. It doesn't matter how late you are. We got it. What is the value? It was 2797. 2797. And really, with our memoization, this is quite fast. Let's do a bit of a hyperfine on it. I think it's sub like second, probably like 20 milliseconds is what my bet is. 700 microseconds, but that was also only 100 runs. So let's do 10,000 runs and 100 warm-ups. 700 microseconds. Never mind. 20 milliseconds was very, very, very wrong. I don't really know that there's a whole lot for us to optimize. I think the biggest optimization that we could have done was to add this memoization. And so I'm glad to see that that paid off. I'm going to break out the connections or the parsing into its own function. And this returns a hash map of string to value or to input. And it takes in input as a stir. And then connections here is going to be parse. That way it's a little bit more readable. I would say that this is probably our cleanest solution so far. One thing I can think of is really just like hash map with capacity, not with hasher. I don't think it's worth doing like a custom hasher or doing like a faster hasher because we're not doing a whole lot of hashing, I think. And they're fairly small maps. Like how many inputs do we have? Not that one, but day input day 7 has only 340 inputs, so it's not exactly a whole lot. Let's literally just do a capacity of like 1,000 and see if that changes the performance at all. Oh yeah. And then here we could also say like let memo is not default, but a hash map. And then we have to like quote reset all wires, and so that's going to be basically memo clear. And then here we're going to say memo again, and just see if that changed anything. I mean, it seems to have saved us like 20 microseconds, but that could also like just be noise. It's kind of hard to tell. Also, I did say that we're supposed to set a timer, but let's just 5 minutes, I guess, because we're already a couple of minutes in. What else? So the other big thing that I notice is this parsing, but I really don't think that that's annoying. We'll just turn off the bar. I don't think that it's really a large amount of time. Let's say parse time is instant now, and then debug parse time.elapsed, just to get a rough idea of how long it's taking. If we cargo R, 68 microseconds is not insignificant. Yeah, so 72, 50. It's interesting that part 1 takes significantly longer, but I think that's probably something to do with like caching. And I do want them to parse independently per part. We could like technically move the parsing, but it doesn't really. First of all, it doesn't really matter, but also it feels a little bit like cheating. What can we fix? So let's do a quick like perf record on this. I don't think, yeah, see, the problem is it's only got woken up twice. It's just running way too quickly, and I could increase like the sampling rate, I think, but it still runs in less than a millisecond. So there's not a whole lot that we could do in terms of profiling. I guess something we could do, let's create a part 3 where the part 3 is literally do this 100 times. And like, obviously that's not going to really matter. And certainly not going to equal 100. The chance of that is really low. But at least this way we can see like what the actual value is gonna, or like where most of the time is being spent. So if we cargo run this, I mean, it's still basically instant. 248 milliseconds, or 248 milliseconds. Let's do it 10,000 times. It's still so fast. What if we do it 100,000 times? Okay, that's a little more profilable. I'm literally gonna, or I'm also just gonna disable these guys. Yeah, so now we're taking 1.9 seconds, almost 2 seconds. If we perf record this. What? Oh, I need to do this command to actually build that. Okay. If we do perf report -g, are we going to get anything useful in here? So we see value resolve takes the most time, perhaps unsurprisingly, and a large amount of that time is looking up in a hash map, also completely unsurprising. Can we make that nicer? So one thing is we could use like strings, or we could use like byte arrays instead of strings, which is not awful. I don't think I can go into this any further. Yeah. Okay. And then also string cloning is slow. Where are we doing this string cloning? I don't know. Can I? No, I don't know where we're actually doing this cloning, but that cloning is also taking up some time. So let's see, clone. When we insert, we clone. That's unavoidable, I think. Or when we insert into the memo, we clone. I say that's unavoidable. That's actually wrong. You know what I think we can do? I think it's okay to say leak on this, which gives us a can I do that? Okay, timer's going off, but we're gonna ignore that for a bit. So the idea here is with leak, just like box leak and the similar function, it will like actually just leak the memory, which means that it will, I mean, it won't free it, which means that it's now a static stir, meaning that instead of using strings everywhere, so basically everywhere we use a string, I think we can just globally replace string with, fuck, you have to escape that, static stir, like that. And now everything should be fine. There's a couple of issues. So then this method call chain might not have the expected associated types. So yeah, because we're calling toString here, which we don't want. Same thing here. Actually, let's, before we make all this change, like even before this part 3, when we were doing this, yeah, okay. I just want to add day 7. And then we can redo all of this again. Just so we have a point of like, hey, we know that this works and we know that this part works well. So we can reset back there if necessary. Value of types that cannot be built from iterator over of types ref, stir. You would be correct. I don't think I need this. Right, you're also static. And you're also static. Static. I do need these brackets though, right? Yeah. And you're also static. Cool. And you're also static. Cool. So now, nope. God damn it, we're close. Static. Oh wait, from stir can't be from static stir. This is part of the reason why I didn't want to do this initially, but that's fine. From stir is now like this. And it's infallible, which means we don't need to wrap it. Okay, but now we need to say value from stir. And value from stir x, value from stir y, same thing there. Value from stir x, value from stir x, value from stir x. Cool. This is also part of the reason why we move that into its own dedicated function, so we only have to change it once. You don't need into, you don't need into. Okay, if we or I guess if we cargo R, how long do we take now? It's a little bit slower, or a little bit faster. Did we hyperfind last time? I don't think so. It does not look like it. So let's, first of all, get rid of all of these warnings. Unused is fine. That can go away. That can go away. All of these can go away except for hash map. Unused can stay. Just so that it stops warning, because that's annoying. Oop, I'm sorry. I don't know if you could hear that, but I just bumped the mic. Okay, if we run this, we get 1.39, 1.389, whatevers. I want to get stash, and then let's hyperfind this. We'll run this 100 times, so that'll take about 20 seconds with a little bit of warm up. Oh, this doesn't have the part 3. Let's make it have the part 3. Yeah, that should be fine. Go away. And source day 7. let's add part 3, which doesn't take a static stir in here and needs to stringless. And then we need to call part 3. Okay, we run this. Non-zero exit code. Right, because this assert is always going to fail. Okay, and we'll let this run. Oh wait, if it takes 2 seconds, I don't want to do 100 iterations. I don't think it's worth that. We can do 2 warm-up runs and 10 like real runs. Just so we're not sitting here literally all day. Okay, yeah, so we're getting 1.71 seconds. We've got this diff. Let's stash, and then let's pop or apply 1, which gets us back to these changes. So we go from 1.718 to another failure because we're still doing this assert in here. Okay, so actually just replacing those allocations saves a decent chunk of time. That's cool. I'm glad to see that. Yeah, so what's our diff? This seems to just be replacing string to static stir. Actually, let's say day 7. Okay, and then one last change is that instead of this, we can make these be static slices to U8s, which is okay because we know that these are all ASCII. And so ASCII comparison is just like a bitwise comparison or a byte-wise comparison. Let's do replace all stir with U8 and allow me to confirm. So not that, yes that, yes that, not that. Wait, I don't know how to go back. L? Oh. No. That. Where are we? No. Yes. No, 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 no. No. No, no. No, no. Okay. So that's obviously going to break in a bunch of places. Input here is no longer going to be lines. We're going to do split on a new line. And you need that. So split white space isn't a thing anymore, but we can split the same way that we just did on he is a space because we know that they're space separated. This is gonna be annoying. Oh wait, no, it's not. We can just do that. Yeah, I think that's fine. And then we already know that this is a... Okay, so this is a vec of slices. This expression has array of slice. No. Wait. Hold on. Oh, I think it's really just complaining about all of these. I don't think that there should be any issue with this pattern matching with using slices instead of whatever, but I guess we're gonna find out. We can do standard stir from UTF-8, and we know it's already UTF-8, so we can just do unchecked, which means that we need unsafe. And we could technically just parse this ourselves too. It's not terribly complicated, but I don't know that it's actually worth doing that. Okay, so now input is input dot as bytes. That's now a byte array. I really hate that you have to do this. This is that because this is a reference to an array of bytes versus what we need, which is a slice of bytes. And then this is going to be as bytes. And then really, we could also just do as bytes there, but I don't like that. I think we might be able to do as slice. Although it's unclear to me if that's like nicer. I guess it probably is, but I don't care because I like this more. Do I need this reference? Yeah. So reference, slice, reference, slice, and reference, slice. Okay. And this is add bytes. So that should be everything is fixed or not. Fantastic. s.parse from UTF-8 unchecked. S. I mean, I guess in reality, from stir could still just take a stir. That's fine. We'll do this. I don't see any like actual like any actual performance benefits from that. The only thing is it's a little bit cleaner code, but I don't want to rewrite all of that for that. And let's hyperfind this, I guess. So what was our previous metric? We were at 1.173, and replacing everything to bytes gets us up to, or down, ideally, to, okay, it brings us up. That's a little unfortunate. I wonder why that is. Like, what does this function actually do? It should literally just transmute it. Yeah, it should do basically nothing. This vec is still a little bit sad. Do we have collect into? Has that stabilized yet? No, it has not. I mean, the thinking is we can literally say let buff, I don't know what to call it, is vec, or I guess literally call it parts. Parts is vec with capacity 4, and then we literally just say for I in 0 onwards. Or no, we do this dot enumerate parts I equals v, and this way we don't have to this way we don't have to, what's the word, what is the word, wow, brain, we don't have to allocate the vector every time, although I feel like that allocation is very minimal, but then we can parts dot clear. I guess we can just do that before, it doesn't matter. And we failed to run. And the 4 comes from, like, I guess it should be 5. Huh. Out of bounds. Right, this should be push. Not that. So if we run, before we were at 1.2, now we're at 1.2. So that didn't actually change anything. A little bit unsurprisingly. Like, we did that allocation 300 times. It's not a whole lot. I'm kind of surprised that switching to bytes slowed us down. And it's not really clear why. And to be honest, I wouldn't be... What is our diff? So we have... Our diff is switching to bytes. So if I get stash... and we run... Yeah, so it is specifically a switching to bytes cost like 50 milliseconds. But I don't really know why, but also at the same time, I think it's good enough. So we have got no diff, which is cool. So that means that we're all done there. Let's go ahead and push that. And let me actually bring this stuff back. Or wait, I stashed, so I don't know what the current state is. Remove day 7 part 3. Fantastic. I think we'll probably do one more and then we'll be done for today. Unless that one is like a pain and takes too much time. At which point we will be done for today. Anyways. Okay, space on this. Actually, let's get this set up. So 8. Input day 8.txt. Dump that in there. And then Argo Toml, day 8. Okay. Great. Now what? Yeah, now we're gonna copy the template to day 8. And then let's open that. Day 8. Great. That's really bright. Space on the sleigh is limited this year, so Santa will be bringing his list as a digital copy. How modern. He needs to know how much space it will take up when stored. It is common in many programming languages to provide a way to escape special characters and strings, for example, blah. However, it is important to realize the difference between the number of characters in the code representation of the string literal and the number of characters in the in-memory string itself. For example, that is 2 characters of code, but the string contains 0 characters. The ABC is 5 characters of code, but 3 characters in the string data. Yeah, I know how escaping works, that's great. Santa's list is a file that contains many double-quoted string literals, each on one line. The only escape sequences used are // double quote, and like an ASCII character. Disregarding the white space in the file, what is the number of characters of code for string literals minus the characters in memory for values of the strings in total for the entire file? Let's look at this input a little bit. It really isn't even, like, insane. Isn't there, like, a Rust mechanism for decoding string literals? Like, I think there was. Escape debug that escapes each char in self with char escape debug. Escape. Wait, escape default returns an iterator that escapes. I don't know which one is the right one to do here, but I really feel like Rust just kind of cheats here. I don't run sum, I just want to for each L and the debug L. What is escape default? Oh, is escape default like an iterator over characters? Collect into a string. So if we then cargo R, what do we get? No, cargo R on that, what do we get? Okay, that is wrong. I don't want escape. I realize that this just gives you like... Wait, both are equivalent to backslash? Oh no, this transforms it into the debug string. Do we have an unescape? No, I don't think so. Okay, this does it the other way. This is the wrong way. That's fine. That's fine. That's fine. That's fine. It's fine. I said it's fine. Okay. So what do we do instead? First of all, for each line, we need to... first of all, I guess input lines. Then we're going to say line. We can trim the outer quotes. So from 1 to line len -1. If we debug that line, I want to keep the OG, or the code as they call it. So we get, like, for this one, we get quote \c. Oh, this is debug printing, so it's actually kind of annoying. Let's change this to be ePrintLine. And we'll say this goes to this. And we'll put brackets around it because we're super high tech. So we go code goes to line. Yeah, and that one's a little bit easier to read. So you get that goes to that. And then you'll notice that we're not escaping, which is fine. One thing to note, though, is that we don't actually care about the... God damn it. I keep pressing the wrong buttons. We don't actually care about the content of the string. We only care about the number of characters it takes up. Yeah, we only care about its length. So, what we can do is... For... No, we don't want to do a for loop. Let mut I is 0. Mut... I want to do while I is less than line.len. And I guess this is len. If I is a backslash, double backslash, then in this case, we need to peek at the next character. Something interesting to note. No, I was going to say we don't need to look at the last character. We can assert here, and I'm going to do a debug assert, that I is less than line.len -1. Because if we have a backslash at the end of the line, then it's just invalid. And this is line at I. And actually specifically, so... I was gonna hold off on like doing the bytes so we don't have like preemptive or premature optimizations. But I don't know that there's actually like it just kind of makes this a little more difficult, like walking character by character. So I want to do bytes split, or I guess as bytes split would be is a new line, and then we'll slice into code again. And I still want to like print these nicely. So from UTF-8 unchecked. I don't even care about printing this, to be honest. Okay, so we have I want len to be up here. And then at the end, we're going to say I++. Wait, we're in Rust. What? I plus equals 1. Okay, so we know that we're not at the end of the line, which means we can say match I line at I plus 1. So if we get X, then we know what? Then we know that we have 2 more bytes. So we say I plus equals 1 for the X. And then we have like 2 things here. So plus 3, I guess. And then we're going to say line plus equals 1 because we have 1 byte. Sorry, not line, but len. Then if we get a backslash, then we can just say I plus equals 1 to skip that, and then len plus equals 1 plus equals 1. And then finally anything else, and we're gonna just panic. No, yeah, we're gonna panic, but I think we also support double quotes in here. And then down here, we're gonna have a let mut sum is 0. And then we're gonna say, sum plus equals code.len minus len. And then we just return sum. I think that's right. And then what is the ultimate value? So it's 1333. We get the wrong number. Hell yeah. Fantastic. So what is... okay, what is the number of characters of code for string literals minus the number of characters in memory for the value of the strings? Oh, we kind of skipped the else. Wait, but we still got significantly higher. Because otherwise we just need to increase the length. So let's also... Yeah, let's add input day 8 example. Which I guess is this. ABC. AAA backslash quote AAA. Backslash X27. So now if we run on the example, it'd be interesting to like automatically do the example if we're running a debug mode. Although not terribly useful, I think. Just interesting. Okay, so let's do line at I plus 1 as char. So we do get quote and we do get X, but we get 12. So I want to, oh, but we don't have the, like we don't have the string, but we do have the total. So code len is 2, but actual len is 0. Code len is 5, actual length is 3, that's fine. 10, 7, 6, 1. 6, 1. So all of that's correct. That means that our thing here is wrong. Number of characters for the string literal minus the number of characters in memory for the values of the string. But we're getting 12. Oh, which is correct. which means we have an issue somewhere else. Oh, no, wait. So if we get a backslash... Okay, let's remove that. Oh, that time it passed. I don't think I changed anything. I literally don't think I changed anything. Why is it passing now? I'm so confused. It's fine. I'd much rather be confused than have it wrong. I mean, I take that back. That's actually just not true. So one thing I'll notice is that no matter what the path is, the length always gets increased. So we can remove that. We can say I plus equals just so this is a little bit more flat. Albeit a little bit more rusty. This debug assert, I mean, it doesn't actually get brought into like runtime, so it's fine. Let's run that. 600 microseconds. That's good enough. Okay, part 2. Well, let's grab this value, 2046. Now let's go the other way. In addition to finding the number of characters to encode, you should now encode each code representation. Encode each code representation as a new string. Find the number of characters of the new encoded representation, including the surrounding double quotes. That is easy, actually. So that goes there. Sum is this. The total number of characters to represent a newly encoded strings minus the number of characters of code in each original string literal. Hold on a second. We don't need to, we don't care about any of this. This just popped into my head. Hold on, let's undo all of that. We don't need to care about the length. We don't need to care about the sum here. This is literally just sum plus equals 2, and this is sum plus equals 1 plus equals 3. What? Explicit panic on line 13? How? What changed? Wait, what? $114. Char from R. Sir, from UTF-8. And I'll use the checked version so I don't have to... Oh my god. So I don't have to unsafe, but... Mainly because unsafe is more things to type. What is the issue here? Backslash, backslash... Oh, we still need to I. We still need to increment I. Okay, and now we get the wrong number. Because everything still needs to add 2. For the beginning and ending quotes. Yep. Okay, so we don't actually need to do any of the, we'll give that debug assert. We don't need to do any sort of weird stuff there. We literally only need to increment anytime we need to remove characters in here for the number of characters we need to remove. So in this case, we remove 3, which is the X something something. In this case, we remove the 1, which is the second backslash. Right, or I guess because we take backslash X number, and it goes to some symbol. We'll do what's a fun symbol? I don't know. That. We'll do, oh no, it doesn't even matter. I don't know why I'm spending so much time on this. But symbols are fun to do. Let's give me, whatever, that, sure. So we take these 4 characters, all right, I guess that's ASCII, so that. We take these 4 characters, and then we turn them into 1. So this is 4 minus 1. And then in this case, we take 2 characters, and we turn it into 1. So it's 2 minus 1 gives us 1. Great. That is a good revelation. I don't think it changed like performance or anything, but it's cool to see. Okay, and then all of this is going to be basically the same. We don't want to have a separate line. Although we could, although I don't think it actually matters. And then here we're going to say for B in code match B. So if we get a quote or a back slash, then we're going to say sum plus equals 1. Everything else does nothing. And I'm using match here just so that we have the pattern matching and it looks halfway decent. This could be an if statement. Oh, that's a thing we could do. Yeah, fuck it, we'll do that. It looks horrifying, but it works. And it's wrong. Why? Oh, we always need to do sum plus equals 1. Now it's too much. When do we not need to do sum plus equals 1? Oh, no, we never need to. We don't need to do that there. Total number of characters to represent the newly encoded strings minus the code. So new characters that need to be added to represent this. Let's run it on the example. Make it 12 again. Oh, for the first part. We get 11, which is wrong. Quote encodes to quote. Oh, there's 2 for the outsides. Wait, not a quote there. 19. Perfect. So that is correct. And I think that's correct. Cool. Let's hyperfind this, although I'm gonna bet money that it is already really, really fast. We definitely need more warm up than that. Yeah, it's really fast already. I don't think there's really anything we can do to improve the performance of this. We're already using bytes. We're already iterating as little as we possibly can. One thing actually for this one that's interesting is we don't need to split by string. So we can literally just iterate over the bytes. And then if we get... let's replace this back with a match. If we get a new line, we just need to add 2. Let's cargo R on that. So we're off by 2 for the first line, right? Like, we're not adding the 2 for the first line. So I'm going to literally, bam. And I don't think that'll really change anything. Maybe it saved a microsecond. So no, it didn't really change anything. Or maybe the compiler just kind of figured that out for us. Either way, this is kind of fun. Let's see. I don't think there's anything else that we can really change in this function. It's already basically as empty as it can get. I don't think we can remove this branching. I don't see any obvious way to do so. And then on this side, we do split by new lines. Do we have to? So if we get our first string, go back to our input day 8.txt. On our first string, we have this quote. So like if we were to put these in like a line, we basically end up with like that. So we get quote, which we need to ignore. Interesting. So right now we say sum plus equals 2 when we remove the quotes. So what is this? So the sum is the number of removed characters. So we remove the quotes for the like the outside quotes. Interesting. I don't think we can trivially replace this with just bytes. So I'm gonna skip that one. I don't think there's really much we can do there. What else? What else? So this slicing isn't necessary. And we could just do that. I don't think that'll be any performance change, but it's a touch simpler. Technically, it could have potentially saved like a microsecond, but again, that's literally a microsecond and it's fake. What else? So if we have a backslash, then we do stuff. That's a fairly rare case, so I don't think branch prediction is a big deal there. What else? What else do we have? Yeah, I don't think there's really anything else that stands out to me for like quick improvements. And since we're already less than half a millisecond, I think it's okay that we can't get any better improvements there. But let me commit this and push it. That will put it into here. No. Into AOC optimizations. This guy. Right about there. And I think that's going to be it for today. So thank you everybody who's watching, and I will see you next time.